This is what actual C-sharp code looks like. It looks like a mess when you don't understand it, but there are a few syntax rules. Those are rules between you and the computer, which makes it easier for you to follow along. Uh, Syntax is a compromise. The computer doesn't understand English and you don't understand the computer. But by having certain rules, then you can follow those and the computer will try to interpret what you're writing. One such thing is a statement. If you write a line of code that ends with a semicolon, then that is a statement, which is a CPU instruction. As you can see, there are 5 statements in this document. CPU instructions are commands for the computer to do something. There are other rules as well. For example, if a line starts with 2 slashes, then it is a comment. So all the green lines are just for you. The computer will ignore them. Okay, so what do these statements actually do? Well, they do several things. The first thing that you're going to learn is something that you will use a lot. Everything needs to be moved from the hard disk to RAM, to memory, so that the computer can work with it. So the first thing you need to learn is how to allocate memory. And that is done in this line here. It is called declaring a variable. And you do it in 2 parts. The first part here is the data type. It tells the computer what kind of memory slot you want to make. In this case, it's int, which means an integer, a whole number. And then you also need to provide a label. And the label of a variable is the same thing as the name of a variable. This is the name of the memory slot that you will later use in your code to reference that memory slot. I should also probably say that picking the right data type is important. It makes your code faster, and sometimes it can even crash if you pick the wrong one, so it makes the code more robust. And a label must be unique within its container. You cannot have 2 variables with the same name. However, they are case sensitive, so high score with all lowercase letters is not the same label as high score with all uppercase letters, for example. Now that we have declared a variable, we can use it. So in the second line of code, we are using the label. And here we are assigning data to the variable. You can see that because you're using the equal sign, which is called the assignment operator. And you're storing the value 1000 in high score. The word initializing is used the first time you assign to a variable. And if you don't initialize a variable, it will have a default value. The computer will initialize in variables to depending on the data type, for example, if it's an integer, the number 0. If it's not an integer but an object, then it will be null. If it is a string, the string will be empty from text. You don't know what an object is yet, but we'll get to that later. Methods are groups of statements. Here's a method that are contained within brackets, curly brackets. Between this bracket and this bracket, there are statements, and they're all inside a single method. The method name must be unique within the container it is in, and methods are grouping statements for a purpose. Each method performs one task. Since it should only perform one task and not several tasks, then it should be pretty short so that it is easy to read. It should probably be less than 20 statements inside a method. As you can see, we have two methods. We have a method called unique method name, and down here we have another method called print score. Since you can have any name you want on a method, the computer doesn't know which method to run, which statements to execute. So you need to tell it, and you do that by calling methods. You can see a call down here. A call consists of two parts. First, you write the name of the method you want to call, and then you can pass any information you want to that method. So the code on the screen is something like this. First, we make a memory slot, then we store the value 1000 in the memory slot, in the variable, and then we call the print score method, and we pass it the value 1000. After the computer has executed these three statements, then when it gets here, it will jump down to print score. The first thing print score will do is declare another variable, and it will automatically assign 1000 to it because that's what we passed in. These variables up here are called parameters, and then it will execute any code that we put in here, probably to print the number 1000 on screen. When it gets to the end here of the print score method, then it will jump back to where it left off, which means that when it's done with print score, it will keep going here, and then it reaches the end of the method. Now there are two more concepts about methods that you should know. Just as we can pass a variable into another method, a method can send a variable back. It is called returning a variable. We're not going to do that today. That is why we have the word void, because this method doesn't return anything. Actually, this one doesn't return anything to whatever is calling the unique method name. Methods also have scope, which means that the variables inside the method, such as this one is declared inside the method, has method scope. This means that this memory slot will be deleted. It will be removed from memory once we reach the end of the unique method name method. Now, classes are actually declared with the keyword class, and they are containers that contain a lot of methods. They can actually contain variables as well. If a variable is declared in the class, that means that the variable has class scope and it will not be deleted until we delete the class or delete the object. Uh, we'll get to that in a little while. Class names must be unique as well. The goal of the code, of the design of the code inside a class, is reusability. This means that all the code inside the class should have a common purpose. For example, you can design a class to play music. So you have perhaps a method to play music, and you have a method called stop, and you have a method called pause. If you wrap it up nicely like this, then it is called reusability, because you can take the entire class, copy it, and paste it into any program you want. And if you have made a good design, you should be able to just play music in that other program without actually adding that much code. Let's take a look at the code in the class as well. The first thing we do here is that we create a variable, just like we did down here. However, this one is of a different data type. This one is of a special data type. It has a class name as the data type. That means that we're creating a memory slot that will store code. Remember that we have to move everything to RAM, which includes code as well. And then we have to label that class, that code block that we move into memory to. And when we have packed up a class, it is changes name to be an object. So basically a class is code while you are in the editor, while you're coding, while you're making code. But once everything is packed up and put in RAM, then they are called objects instead. So how do we pack up an object? Well, you can see that when we do the high score, we just assign a value to it. When we pack up code, we do almost the same thing. We assign to a variable. However, we use the keyword new to signify that we're packing up a class into an object. And instead of writing a value, we write the name of a method that will be executed which will be called as the first method called of that class. This method is called a constructor, and it always has the same name as the class itself. So the class that we are trying to pack up in this line of code, the entire class must be called class name. And then the method inside must be called class name as well. The good thing about C# is that this is about memory management. Other programming languages, they have a destructor as well, not just a constructor. The destructor method is the last method called before you delete an object. This is done automatically by C#. There is something called a garbage collection system, which will clear up memory for you, so you never really need to use a destructor. You can, however, still implement a destructor. We probably won't do that very often though, because I like the automatic feature of C Sharp. The last concept I want to talk about is a namespace. They also need to be unique, and namespaces contain classes. Namespaces cannot contain any code, any statements by themselves. Uh, they are just a way of sorting things into different containers. One way to look at it is to say that a class is a file containing a lot of data, containing a lot of statements, and a namespace is a folder which can contain several files. I can show you. One listens to the KLF, but she only likes the later albums. I, however, listen to their old music and their new music. We have both got the White Room available. They contain these two folders, Göran's music and one's music, contain things with the same name. If the White Room file folder contains a file that has the same room as the White Room file over in my folder, then that is not a problem because they are in different folders to start with. So folders are a good way to sort files, and namespaces are a good way to sort classes. Now there are some freaky things that we have not yet covered. There are, for example, variables declared in a method are called variables, and variables declared in a class, they are called fields sometimes. There are also specialized methods, such as properties. Those methods, they only change fields, they don't contain any other kind of code. And there are also specialized methods called events, which are called by Windows when a variable is changed. Doesn't much matter. We'll get to them later. I want to move on to some code, real coding instead in Visual C Sharp. One thing you can note though is that it doesn't much matter if it is a field or a variable or property or event or method or whatever. The collective name for all of them, all the things that are stored inside a class, are class members. Members. Okay, let's code something for real.